significance of dimensions. Now look at me. We did dimensions last class, correct? Now, what is the use of dimension, or what is the real life application of dimension? I don't want to see the fan, balcony, other one. If I cannot see your face, I'm going to throw it out, okay? What is the application of dimension? Okay, let me once put people out who have switched off their just. Okay. By 110, if your cams are not on, then don't ask why am I in the waiting room. Okay. Now, what is the real life significance of dimension? What is the real life significance of dimension? There are three importance of dimension. Means there are three uses of dimension. Today we will study one use. Next class we'll study one, and after that we'll study one. Okay. So the first significance of dimension. So write on the side heading: significance of dimensions. Significance of dimensions. Right now, significance of dimensions. First significance, right now. First significance. First significance is to check the correctness of an equation. The first significance is to check the correctness of an equation. The first significance is to check the correctness of an equation. Now, what does this mean? It means when an equation is given to you, you have to find out whether that equation is correct or not correct using dimensions. Okay, I'll show you one example. You have to understand. Okay, so if an equation is given to you, you have to find out whether the given equation is correct or the given equation is not correct. Now, how will you know whether the given equation is correct? For that, look at the screen. Example is find out whether, just don't write, listen. Find out whether V is equal to U plus AT is dimensionally correct. If this is the question. Find out whether V is equal to U plus AT is dimensionally correct. Now, how many terms does this particular equation have? Answer is 3. I'll tell you how 3. This is 1. This is 1. And this is 1. Correct, all of you? There are 3 particular clusters. One is V, one is U, one is A into T. Forget equal to an addition sign. How many terms are there? 3. V, U, and A into T. Now, what does V stand for? Final velocity. What does U stand for? Initial velocity. What does A stand for? Acceleration. And what does T stand for? Time. Repeat. What does V stand for? Final velocity. What does U stand for? Initial velocity. What does A stand for? Acceleration. And what does T stand for? T stands for time. Now, tell me, what will be the dimension of V? Means what is the unit? What is the unit of velocity? Unit of velocity is meter per second. Therefore, what is the dimension of velocity per meter per second? L1 m0 t minus 1. Can I say this is the dimension? Now, what is the dimension of U? Initial velocity. Means what is the unit of initial velocity? The unit of initial velocity is also meter per second, because ultimately it is velocity itself. Therefore, what is the dimension of initial velocity? Same. L1 m0 t minus 1. Now let us find A into T is how much? What is the unit of acceleration? Tell me, what is the unit of acceleration? Meter per second square into time. Time is second. Therefore, 1 second and 1 second will cancel. I am left with meter per second. Now, what is the dimension of meter per second? L1 m0 t minus 1. Therefore, do you notice for each box I got one dimension for each box? Can I say for each box, I got one dimension, this, and this. Are all three dimensions same? Are all three dimensions same? If yes, then the equation is dimensionally correct. Then the equation is dimensionally correct. Did you understand what to do? Any equation, you have to group them. Each group you will get one dimension. For example, for this group, I got this dimension. For this group, I got this dimension. And for this group, I got this dimension. All the dimensions, if they are same, then the equation is dimensionally correct. If any one group has different dimension, then the equation is dimensionally wrong. If all three groups have same dimensions, then the equation is dimensionally correct. Otherwise, if any one group has wrong dimensions or different dimensions, then that equation is dimensionally wrong. Therefore, make a note of this. Example 1, V is equal to U plus AT. So make a note of this particular example. Now let us do one more example. Look at the screen. V square, listen. V square is equal to U square plus 2S. This is the equation they have given. And I have to find out whether this equation is dimensionally correct or not. V stands for final velocity, U stands for initial velocity, and S stands for displacement. Therefore, first, how many groups can I make? I can again make 3 groups, 1, 2, 3. Now, the first group is V square. Now tell me, what is the unit of V? It is meter per second, but it is V square. Therefore, I will write it as meter per second the whole square. Now, meter per second the whole square is nothing but meter square per second square. Now, meter square per second square, the dimension is L2 M0 T minus 2 for the first one. Now, U square, what is U? What is U? Initial velocity. Now, what is initial velocity? Initial velocity is meter per second the whole square. Now meter per second, the whole square is nothing but meter square per second square. Now meter square per second square is L2 M0 T minus 2. Now 2 into displacement, 2 does not have any unit. Displacement is meter. Therefore, my final unit is meter. Therefore, what is the dimension of this? Meter. L1, M0, T0. Now compare the final three dimensions. 1, 2, and 3. Are all three same or something is different? Can I say these two are same, but this one is different? Therefore, if any one is different, what do we conclude? This equation is dimensionally, incorrect. We write this equation is dimensionally incorrect. How did I conclude? Because all three dimensions are not the same. Clear? Therefore, make a note right now. Now I will give you one equation. Now you have to solve and tell me whether this equation is dimensionally correct or not correct. Then I will also do it on the screen, but first you tell me whether this equation is correct or not correct. V square is equal to U square plus 2AS. This is the equation. Now do dimensional analysis, get the dimensions and tell me whether this answer is dimensionally correct or dimensionally not correct. Okay. I got some answers saying dimensionally correct, some saying dimensionally incorrect. I will show it to you. Then you tell me whether your answer was right or wrong. Okay. So first I will divide them into boxes. So can I say this is my first box? Can I say this is my second box? And can I say this is my third box? Now, if I look at my first box, V square. Now, V is final velocity. Now, final velocity will be meter per second the whole square. Meter per second the whole square will be meter square per second square. And the dimension for this will be L2 M0 T minus 2. Now, U square is also meter per second the whole square. It is also meter square per second square, which is what? L2 M0 T minus 2. Now, when I go to 2AS, 2 does not have any unit. Acceleration is meter per second square and displacement is meter again. Therefore, meter into meter will be meter square per second square. Therefore, if I go to do the dimension, it will be L2 M0 T minus 2. Therefore, this is the first answer, this is my second answer, and this is my third answer. Are all three same? Answer is yes, all three are same. Therefore, can I conclude that this equation is dimensionally correct? Can I conclude that this equation is dimensionally correct? Therefore, I can write it is dimensionally correct. So people have given me the answer that this equation is dimensionally correct, have given me the right answer. For people who have said that this is dimensionally wrong, just check what mistake you have done, correct it and let me know. Okay? Okay, fine. So can we start with the next question? Or you need time to copy? Okay, copy it, then we go to the next question. Half mv square equal to mg where m is mass, v is velocity, and g is nothing but acceleration due to gravity. Now do this problem, do your dimensional analysis, and tell me whether this equation is dimensionally right or not dimensionally right. Start. Okay, I will see your answers, and most of you have given me the right answer. Okay, now let me show you the answer on the screen. Tell me if you have got the same method and the same logic. So first thing is I can divide this equation into two groups. Half mv square is one group and mg is other group. Now half mv square, half as no unit, mass is kg, and v square, velocity square, is meter per second the whole square. Therefore, can I write as kg meter square per second square? And this will be LMT L2 M1 T minus 2. Similarly, mg, mass is kg, acceleration due to gravity is same as acceleration. Acceleration due to gravity is same as acceleration, which is nothing but meter per second square. And kg meter per second square, kg meter per second square. Therefore, finally, our answer became this and this. Are the two dimensions same? Answer is no. One is L2 M1 T minus 2. One is L1 M1 T minus 2. Therefore, the conclusion is the given question is incorrect. The given question is incorrect. Okay. Make a note. Dimensionally incorrect. Next, find out whether this equation is correct or incorrect. Half mv square is equal to mgh. Start and tell me whether this equation is dimensionally correct or incorrect. So look at this. Look at this. Half mv square is equal to mgh. So again, I can divide my equation into two. This is the first part and this is my second part. Just 1 minute, okay?
माझ्या टेबलवरती होतो ठेवतो आणि जसं होतं तसं ठेव मी लावून दाखवलं मला क्लासेसच्या मध्ये तू अरे इकडे होतो मध्ये
I've got many people saying that this answer is dimensionally incorrect. We'll just check. See this. Half mv square. Half has no unit. Mass is kg. Velocity square is meter per second, the whole square. So it is kg meter square per second square. So kg meter square per second square, L2 m1 t minus 2. mgh. Mass is kg. G is acceleration due to gravity, means same as acceleration. Meter per second square. Height is meter. Therefore, it is kg meter square per second square. So kg meter square per second square is L2 m1 t minus 2. Therefore, if I compare this and this, can I say both dimensions are same? Therefore, this equation is dimensionally correct. So for people who have answered that this equation is dimensionally correct, very good. Others who have said that this is wrong, just check why you have told me it is wrong. It is correct. Okay. Find out whether this equation is dimensionally correct or not. T is equal to time. L is equal to length. And G is equal to acceleration due to gravity. Start. Find out whether this equation is dimensionally correct or not. Okay. Now, answer. I will show it to you. Now, I can divide this. I can divide this question into again two parts. I can divide this question into two parts. One is this box and one is this box. So t is time. So t square will be second the whole square. So it will be second square. And the dimension of second square will be L0, M0, T2. Now, this one, 4 has no unit. Pi square has no unit. L is meter. And acceleration due to gravity is meter per second square. Meter and meter will cancel. Second square will go on top. Therefore, my answer will be second square. And therefore, it will be L0, M0, T2. Therefore, I got both of these answers. One is this and one is this. Can I say both have the same dimension? Therefore, this equation is dimensionally correct. Therefore, this equation is dimensionally correct. Make a note. This equation is dimensionally correct. Easy. This equation is dimensionally correct. Now, in your book back, they have given one question. We will do that question also. See here. This is in your book back, page number 15. If you have your textbook, you can check it. This is your book back question. And the question is question number 9. Just check. Question is question number 9. Just check. Look at the screen first. What they want us to do is, please look at the screen. They have given one equation, V is equal to K into square root of GH. Now they are asking us to show that this equation is correct. They are asking us, show that this equation is correct. Now how do you show? Make two boxes. Get the dimension of both boxes. If the dimension is same, then can I say this equation is correct? Now tell me whether this equation is dimensionally correct or not. V is velocity, K is constant, G is acceleration due to gravity, and H is the height. So show me or prove that this equation is correct or not correct. So start. How will you do it in the same way that you have done? Start. Did you prove it? Now let us prove it. V is equal to K into GH. So can I say this is one box? Can I say this is another box? Correct? Therefore, Jenny, listen to me carefully now. V is meter per second, correct? Velocity. Now, what is meter per second? Meter per second is LMT. Meter is length, mass is 0, second is T power minus 1. So one dimension we got. Now K into square root of GH, K does not have any unit. Square root of G. What is G? Acceleration due to gravity. It is meter per second square. Into height. What is the unit of height? Height is meter. Therefore, I will get square root of meter square per second square. Or I can write it as square root of meter per second the whole square. So can I say square root and square will cancel? Therefore, I will get meter per second itself. Therefore, what is the dimension? Can I say L1, M0, T minus 1? Therefore, can I say the dimension is same for both? L1 M0 T minus 1. Therefore, can I say this equation is correct? That is what they have asked us to prove. To prove using dimensional analysis that this equation is correct. I proved it. I got two dimensions. Both the dimensions are same. Therefore, can I say that this equation is dimensionally correct? Check. Easy. So for people who have told this is incorrect, in fact, most of you said that this equation is incorrect. You have to prove that it is correct so that it is on the screen. Any doubt in this question? It is in fact your book back question number 9. So be very careful with such questions, especially book back questions. I think page number 14 or 15, it is there. Okay. Can we go to the next one? Now, in your book back, page number 14, they have asked us question number 2. Just check. Within 2, question number 2, they have asked here, what are the dimensions of the quantity L into square root of L by G? That is what they have asked, where L is length and G is acceleration due to gravity. Therefore, my question to you is, can you get me the dimension of this quantity? L into square root of L by G. Start. Get me the dimension of this quantity. L into square root of L by G. Okay, now let me show you the answer. What is the dimension of the quantity L into square root of L by G? Now, listen to this. What is L? L is meter. And what is square root of L by G? Meter upon, what is G? Acceleration due to gravity. Therefore, can I say it is meter upon second square? Therefore, meter and meter will cancel and second square will come on top. Therefore, it is meter into square root of second square. Therefore, square root and square will cancel. Therefore, I am left with meter into second. Now, meter into second is L1 M0 T1. Are you getting this, all of you? Meter into second. Meter is length, second is 1. Therefore, answer for this question is L1 M0 T1. Now, my question to you is, this is the question in the textbook. My question is something different. Can you get me the dimension of L into root LG, not L by G? Can you get me the dimension of this quantity? L into root of L into G, not L divided by G. Start. L into root of LG. Start. Okay, I think most of your answers are right. I'll also do it. See here. L into root LG. L is meter into square root of L is meter and G is meter per second square. So that is meter into square root of meter square per second square, or that is meter into square root of meter per second the whole square. So square root and square will cancel. Therefore, it is meter into meter per second. It is meter square upon second. Tell me, are you getting this much at least? Meter square upon second is L2 M0 T minus 1. Are you getting this? L2 M0 T minus 1. L2 M0 T minus 1. That is the answer. Did you understand this? Therefore, the question might be L into root L by G or L into root of LG. The question can be anything. Your answer you should know. What should be your answer? Clear? Okay. Now, we have finished 2 questions from book back. Now let us do the MCQs from book back. Now look at the first question and tell me what should be the answer according to you. L1 M1 T minus 2 is the dimensional formula for what? This is the question. Start. Put your answer. Put your answer in the message box. A, B, C, or D. Okay, look at this. Look at this. L1 M1 T minus 2. L1 M1 T minus 2 is the dimensional formula for. So L1 M1 T minus 2. L1 means length 1. Length 1 is meter. M1 means kg. Therefore, it is kg. T minus 2 is upon second square. Therefore, kg meter per second square is the unit of what? You know that kg meter per second square is the unit of force. I told you in the first class itself. Please remember, okay, again I'm telling you, kg meter per second square is force. Kg meter square per second square is energy. This you should remember always. Repeat in your mind. Kg meter per second square is force and kg meter square per second square is energy. Energy, work done, heat, all are same. I'll repeat. Kg meter per second square. Whenever I ask you what is the formula, what is the dimension of force, you should tell me the unit of force is kg meter per second square. And if I ask you what is the dimension of energy, it is kg meter square per second square. Remember, energy, work done, heat, all have the same dimension and the same unit, joule. Now, tell me the answer for the second one. Light year is the unit of. Start. Put the answer in the message box. Light year is the unit of. Light year is the unit of. Answer will be distance. Can I say light year will be the unit of distance? Because what is light year? Distance traveled by light in 1 year. Distance traveled by light in 1 year. Therefore, light year will be the unit of distance. Therefore, first one answer is C. Second one also answer is C. Did you get it? Okay. Now, tell me the next one. Fourth one. Dimensions of kinetic energy are the same as that of. Dimensions of kinetic energy are same as. I told you energy, work done, heat, all have the same units and dimensions. Correct? Energy, work done, heat, all have the same dimensions. Therefore, what will be the dimension, or the kinetic energy will have the same dimension as that of work. Okay, energy, work, and heat is the same. Therefore, the first 3 MCQs, please look at it again. Tell me if you have any doubt. First answer is C. second answer is C, and third answer is C. Clear? Now, so we have finished the first 1, 3, 4. Now look at the fifth one and tell me what should be the answer for this. Start. Okay. Let me explain. Which of the following is not a fundamental unit? That means which of the following is not a unit to a fundamental quantity? So centimeter. Tell me, what is centimeter used to measure? Can I say centimeter is used to measure length? Now, is length a fundamental quantity? Yes or no? Check the 7 fundamental quantities. Is length a fundamental quantity? Yes. So centimeter is used to measure length. Length is a fundamental quantity. Now look at the second option, kg. What is kg used to measure? Kg is used to measure mass. Is mass a fundamental quantity? Yes. Therefore, option B is also right. Option C, centigrade. Centigrade is used to measure temperature. Now, is temperature a fundamental quantity? Yes. Therefore, option C also is right. Option D is volt. What is volt used to measure voltage? Is voltage a fundamental quantity? No. Therefore, which of the following is not a fundamental unit? Answer is volt. Now, if you're telling me centimeter, then even centigrade is the answer. Therefore, A and C are not the answers. Answer is D. I hope you understood the logic. Because A, B, and C are all used to measure fundamental quantities. A, B, and C are all used to measure fundamental quantities. D is not used to measure fundamental quantity. D is used to measure derived quantity, that is voltage. Is it clear? D is used to measure a derived quantity, which is voltage. All of you got it? Therefore, we have done 4 MCQs. Actually, second one is out of your deleted portion. So with that, we have completed all MCQs also. All the MCQs are on your screen. So tell me if you have any doubt in these MCQs. If yes, we will solve. If not, we will go to the next one. Okay, so first answer is C. Second answer is also C. The MCQ next one is also C. And the last one is D, that is volt. Okay. Now, let me go to the next one. For example, let me show you one thing. Now listen, I am telling you, listen to me, I am telling you this equation is right. What am I telling you? I am telling you that this equation is right. If this equation is right, find out the dimension of A and B. A and B are unknowns. Find out the dimension of A and B. I'll repeat, I am telling you that this equation is right. From this right equation, find out the dimension of A and B. Start. This equation is right. From this right equation, find out what should be the dimension of A and B. Start. So I'll tell you the logic. Everyone switch on your cam. Let me tell you the logic. How do you solve this kind of problem? Okay, switch on your cam. V is equal to A plus BT. I have to find the dimension of A and I have to find the dimension of B. Okay. Now, since I'm telling you this equation is correct, can I say the dimension or the unit of this and unit of this and the unit of this all will be same? Because now I am telling you that the equation is correct. If equation is correct, can I say each box should have the same unit? Because we have done this in the past. What is the significance of dimension? To check the correctness of an equation. That means if the equation is correct, each box will have the same unit or the same dimension. Now, what is the unit of velocity? Can I say the unit of velocity is meter per second? Someone was saying something?
I'm biased.
I'm biased, correct. The unit of velocity is meter per second. Therefore, can I say each box will have the unit meter per second? Each box will have the unit meter per second. Therefore, can I say directly that the unit of A is meter per second? And what is the dimension of meter per second? L1 M0 T minus 1, correct? Now, can I say B into time is also meter per second? Or B into what is the unit of time? Second is equal to meter per second. Therefore, what is B equal to? B is equal to meter per second square. B is equal to meter per second square. Therefore, what is the dimension of meter per second square? L1 M0 T minus 2. L1 M0 T minus 2. Therefore, I got the dimension of A and I got the dimension of B. Before I get the dimension, I'm supposed to get the unit. Therefore, unit of A is meter per second and unit of B is meter per second square. Did you understand how to solve? If I tell you the dimensions is correct, that means if I tell you the equation is correct, I can use this logic that each box will have the same unit and then I can equate and get the answer. Make a note of this, then I'll give you one more. Okay. Now tell me what should be the dimension of A and B again. Where F is force, T is time. I want the dimension of A and B. Where F is force and T is time, I want the dimension of A and B. Now look at this. F is equal to AT plus BT square. Now I am telling you the equation is correct. Find out the dimension of A and B. Now if the equation is correct, the dimension or the unit of F, unit of AT and unit of BT square, all the units should be same because the equation is dimensionally correct. Now what is the unit of force? Unit of force is kg meter per second square. Therefore, unit of this will also be kg meter per second square, and unit of this will also be kg meter per second square. Unit of both will be all three will be the same. Therefore, A into T is nothing but kg meter per second square. What is T? Second. Therefore, A into S is kg meter per second square, or A is nothing but kg meter per second cube. Therefore, the unit of A is kg meter per second cube. Therefore, the dimension will be kg is mass, meter is length, second cube is T power minus 3. Therefore, the dimension of A is L1 M1 T minus 3. Okay. Now, looking at B, I know that B into T square is kg meter per second square. Therefore, B into unit of T square is second square is equal to kg meter per second square. Therefore, B is equal to kg meter per second power 4. Therefore, B is equal to kg meter per second power 4. Therefore, this is one unit, this is the other unit. So, kg meter per second power 4 will be L1 M1 T power minus 4. Tell me how many of you got this answer right before I started solving. Just let me know in the message. I saw your messages. I think Omkar correct, Samya, Shaunet, others check whether you're getting the right answer. Now listen to one more logic. If the dimensions are same, I can add them. Okay. For example, if two quantities have same dimensions, I can add them. But if they have different dimensions or different units, I cannot add. For example, 40 Newton plus 30 Joule is not 70 Newton Joule. I cannot add quantities that have different units. I can only add quantities that have the same units. For example, your weight is 40 kg and you got 40 in the exam. You cannot say 40 kg plus 40 in the exam equal to 80 marks because you are adding two different things. Similarly, you can only add quantities which have the same dimensions. You can also only subtract quantities which have the same dimension. But you can multiply and divide different dimension quantities. Okay. Therefore, if two quantities have different dimensions, they can only be multiplied and divided. To add or subtract two quantities, they have to have the same dimension. That means only same quantities can be added, same quantities can be subtracted. For example, what is 4 Newton plus 4 Newton? 8 Newton. What is 4 Newton plus 4 Newton? 8 Newton. 4 Newton plus 4 Joule is not 8 Newton, correct? Therefore, I can only add and subtract quantities that have the same dimension. If the quantities have different dimensions, I can only multiply and divide. I cannot add and subtract. Therefore, just write it as a point. Only quantities that have same dimensions, write down as an important point. Only quantities that have same dimensions. Only quantities that have same dimensions only quantities that have same dimensions can be added or subtracted. Only quantities that have same dimensions can be added or subtracted. Only quantities that have same dimensions can be added or subtracted. If the dimensions are different, they can only be, if the dimensions are different, if the dimensions are different, they can only be multiplied or divided. They can only be multiplied or divided. Okay? What did you write? Read it in your mind. If the quantities have same dimensions, only then it can be added or subtracted. If the quantities have different dimensions, they can only be multiplied and divided. Now with that logic, look at this. Find the dimensions of A, B, and C, where E is your energy and T is your time. Find the dimension of A, B, and C. Start. Switch on your cam, all of you. E is equal to A plus B divided by T plus C. Now listen to the logic very well. Since I told you that this equation is correct, since I told you that this equation is dimensionally correct, can I say that this box, and this box all will have the same unit? All will have the same unit. And what is the unit? The unit will be kg. What is the unit of energy? Kg meter square per second square. What is the unit of this also? It will be kg meter square per second square. Over here also it will be kg meter square per second square. Correct? Now, therefore, immediately I got the answer for A, that the unit of A is kg meter square per second square. Now look at this, everyone now concentrate. Now look at this, T plus C means time plus C. Now I just told you that only similar quantities can be added. Only the quantities that have the same dimensions can be added. If the quantities have different dimensions, they cannot be added. Therefore, if I'm adding time to something, can I say that something also should have the same dimension as that of time? Otherwise, time cannot be added. Therefore, can I directly conclude that the C, the dimension of C is same as that of T? That means it is second. Therefore, the dimension of C is L0, M0, T1. Because time cannot be added to any other thing other than time. That is the logic I know. Therefore, T plus something, that something also has to have the dimension of time itself. Therefore, I can conclude that the dimension of C is L0, M0, T1. Clear? Now, look at this. Can I write B divided by T plus C is equal to kg meter square per second square? Means this is equal to this. Now, can I write B divided by, what is the unit of time? Second. Plus, what is the unit of C? Second. Is equal to kg meter square per second square. What is second plus second? Second plus second will be second itself. Second plus second will be second itself. Because what is 4 Newton plus 4 Newton? 8 Newton. I don't say 8 Newton square. What is 4 Newton plus 4 Newton? 8 Newton. That means Newton plus Newton is Newton itself. Correct. Therefore, can I say second plus second will be second itself? Therefore, can I say this second and this second will cancel? Therefore, you are left with kg meter square per second. Therefore, the unit of B will be kg meter square per second. Therefore, I got the final answer. Final answer of A is kg meter square per second square. Final answer for B is kg meter square per second. And final answer for C is only second. This is how you get the dimension of A, B, and C. Are you understanding? Please understand how did I get the dimension of C. I got the dimension of C because the dimension of T and C have to be the same. That is why I concluded that the dimension of C is same as that of time. Clear, all of you? Now, in your book back, there is one question. I will take that question out. In your book back, there is a question. I will take that question out. See here. This is the question. Look at this. They are telling you V is equal to AT plus B by T plus C plus V naught is a dimensionally valid equation. Means they are telling you that the equation is proper. Find the dimensional formula for A, B, and C. Now let me write the equation for you in a better way. V is equal to AT plus B divided by T plus C plus V naught. This equation get me the dimension of A, B, and C. This is your book back question number 10. Start. Get me the dimension of A, B, and C. That is capital A, capital B, and capital C. Answer is given in the module itself. That means answer is given here. You should make it a point to tell me that are you getting the same answer or are you getting some other answer?
Sir got the same answer.
Getting the same answer, I will also show you how. Okay, quickly look at this. V, AT, B by T plus C and V naught all should have the equation is dimensionally correct. And what is V? Velocity. Therefore, all will be meter per second. Even this will be meter per second. Even this will be meter per second. And even this will be meter per second. Therefore, they want the dimension of A, B, and C. Therefore, first I can directly tell you that C is second because T plus C. That means I can only add similar dimensions. Therefore, the dimension of C should be the same as that of time. Therefore, even C should be second. Therefore, if you look at C, it is L0, M0, T1. Now, can I say if I start with A, can I say A into T should be meter per second? Okay, or A into T is anyway second equal to meter per second, or A is nothing but meter per second square. Meter per second square is nothing but L1 M0 T minus 2. Therefore, I got the dimension of A and I got the dimension of C. Now I need to find the dimension of B. Okay, now I can say that B divided by T plus C is also equal to meter per second. Now, what is C? C is also time. Therefore, can I say B divided by T plus T is meter per second? Now, what is T plus T? T plus T is time itself. Therefore, T plus T will be second itself. Therefore, second and second will cancel. Therefore, the unit of B will be same as meter. Meter will be L1 M0 T0. L1 M0 T0. Therefore, this is the first answer, this is the second answer, and this is the third answer. Tell me, are all of you getting the same answer? L1 M0 T minus 2, all of this, A, B, and C. Are you getting all three correct? If you have any doubt, let me know. Otherwise, I'm assuming all three are correct. Okay? Okay. Now, the next topic is called significant figures. The next topic is called significant figures. Write on the slide heading, significant figures. Now, what is significant figures? Let me tell you. They'll give you a number in the exam. Listen to me carefully. They will give you a number in the exam and then they'll tell you find out how many significant figures this number has. I'll repeat. They will give you a number in the exam and then they will ask you to find out how many significant figures this particular number has. Now, to find the number of significant figures in any number, I will have to use 4 rules. I'll have to use 4 rules. So we will go rule by rule. And for every rule, I'll give you example. And once we finish this topic of significant figures, it's a small topic, I think half an hour topic max, we will stop for today. Okay, so I want all of you to concentrate. And as soon as we get done with the topic, we stop for today. Okay, so I want all of you to switch on your camera and pay attention for this last topic. Okay, hardly 20-25 minute topic it is. Okay, everyone? Okay, so significant figures is they'll give you a number and then they'll ask you find out how many significant figures this number has. So how do you find out? How do you calculate? You have to follow 4 rules. Now we will go rule by rule. Okay, we will go rule by rule. So write down rule number 1. You have written the side heading significant figures. You have written the side heading significant figures. Below that, write down rule number 1. Below that, write down rule number 1. Now, what is rule number 1? Write down all non-zero digits are significant. It is there on the screen also. Write this as your rule number 1. All non-zero digits are significant. Make a note. All non-zero digits are significant. All non-zero digits are significant. That is rule number 1. All non-zero digits are significant. That is your rule number 1. For example, how many significant figures are there? How many significant figures are there in this number? Count. How many significant figures are there in this number? Answer is 5. Because all non-zero numbers are significant. Therefore, look at this. This is significant. This is significant. This is significant. This is significant. This is also significant. Therefore, 1, 2, 3, 4, 5. We have 5 significant figures. We have 5 significant figures. Agree? 1, 2, 3, 4, 5. We have 5 significant figures. Now, tell me how many significant figures are there in this number? $34.618. 34.618.
5.
2.
Okay, how many significant figures are there in this number? Answer will be 1, 2, 3, 4, 5. Can I say having a decimal point in the number does not change whether the number is 0 or non-zero? A non-zero number will remain non-zero even if there is a decimal point. Therefore, can I say here also answer is 5. Here also answer is 5. Because what is the rule number 1? All non-zero numbers are significant. Now tell me, how many significant figures are there in this particular number? 3461.8. How many significant figures are there in this number?
5.
Answer will be 5 itself. What logic did I use? 1, 2, 3, 4, 5. All are non-zero. Therefore, I have 5 significant figures. Therefore, 1, 2, 3, 4, 5. 5 significant. 1, 2, 3, 4, 5. 5 significant. 1, 2, 3, 4, 5. 5 significant. Understood? Now, write down rule number 2. Write down rule number 2. So on the screen, I will show you rule number 2. Copy the rule number 2 as it is. After that, we will discuss. See, this is rule number 2 in bold. Copy this as your rule number 2. Right. All the zeros between two non-zero digits are significant, no matter where the decimal point is, if at all. Right. This is your rule number 2. Now, what they are saying, listen to me carefully. Rule number 1 has nothing to do with zeros. Rule number 1 has nothing to do with zero. Rule number 2, listen to me. Rule number 1 has nothing to do with zero. Rule number 2 deals with what if zero comes in between the number. Rule number 3 deals with what happens if zero comes before a number. And rule number 4 deals with what happens if a zero comes after the number. I will repeat. Rule number 1 has nothing to do with zeros. Rule number 2 deals with what happens if zero comes in between the number. Rule number 3 deals with what happens if zero comes before a number. And rule number 4 deals with what happens if a zero comes after a number. So right now we are in rule number 2. What is rule number 2? What happens if zero comes between a number? Now you have written rule number 2. Now let me explain what happens in rule number 2. Look at this number 1, 0, 0, 0, 1. Now, can I say in this number, all of you look at the screen, can I say in this number, Jenny, 1 and 1 are anyway significant because they are non-zero numbers. Now, what about these zeros? Now, look at this 0. Now, does this 0 have a non-zero number on the left? Yes. Does this 0 have a non-zero number on the right? Yes. Therefore, this 0 is significant. Now, look at this 0. Does this 0 have a non-zero number on the left? Yes. Does this 0 have a non-zero number on the right? Yes. Therefore, even this 0 is significant. Now look at this 0. Now this 0, does it have a non-zero number on the left? Yes. Does it have a non-zero number on the right? Yes. Therefore, even this 0 is significant. Therefore, number of significant figures in this particular question are 1, 2, 3, 4, 5. Now, if there is a decimal point, also does not matter. Decimal point may be there, may not be there. This rule does not get affected by decimal point. Even rule number 1 does not get affected by decimal point. Even rule number 2 does not get affected by decimal point. Therefore, now tell me 1.01. How many significant figures are there in this number? 1.01. Therefore, can I say in this number 1.01, there are 1, 2, 3, 3 significant figures are there. 1, 2, and 3, there are 3 significant figures. Now, similarly, tell me how many significant figures are there in all of these. Give me your answer in a single message. 1, 2, 3, 4, 5, 6 problems. Give me the answer. How many significant figures are there in all 6? Start. Calculate and tell me how many significant figures are there in all. Okay. Now, what do we do is, see this. This is the answer. Now check what answer you have given and check this answer and tell me if you have got the right answer. Most of you have given me the right answer. If you feel that your answer is wrong, or if you feel you need justification for any answer, let me know. I'll explain. Otherwise, I hope all of you have understood how these are the significant figures. Got it? To understand how these are the significant figures. Okay. Now, write down rule number 3. Write down rule number 3. I'll dictate rule number 3. No need to write from here. I will dictate rule number 3. Write down. If the number is less than 1, if the number is less than 1, comma, the zeros that come before if the number is less than 1, comma, the zeros that come if the number is less than 1, comma, the zeros that come before the first non-zero number. If the number is less than 1, the zeros that come before the first non-zero number, if the number is less than 1, comma, the zeros that come before the first non-zero number are insignificant, means are not significant. The zeros that come before the first non-zero number are insignificant. This is rule number 3. Now listen to me. Finish writing. Now listen to me. Rule number 1, what does it say? It says nothing about zeros, correct? Rule number 2, what does it say? It says what happens when 0 is there between the number. Rule number 2 says what happens when 0 is there between the number. Now, what does rule number 3 say? Rule number 3 says what happens if 0 comes before a number. For example, look at this number, 0.0007. Now, all the zeros before the first non-zero number, all the zeros before the first non-zero number are not significant at all. Therefore, number of significant figures in this case is only 1 because all these zeros are insignificant. Now remember, rule number 3 is only applicable to zeros that come before the number starts. Rule number 3 does not deal with zeros that come in between the two numbers. For that, again, rule number 2. For example, 0.00708. Tell me, how many significant figures in this case? 3. How many significant figures in this case? Can I say these are not significant because these come before the first non-zero number? This is anyway significant. This is also significant. Now this 0, does it have a non-zero number on the right? Yes. Does it have a non-zero number on the left? Yes. Therefore, it has a non-zero number on the right, plus it has a non-zero number on the left. Therefore, even this 0 is significant. Therefore, number of significant figure in this case is 3. Do you understand? Now, I will give you 3 examples. Tell me how many significant figures are there in this case. 0.008, 0.0080808, and 0.8. Tell me in each case how many significant figures are there. Start. So let me tell you the answers. Okay, let me tell you the answers. The number of significant figures in the first case is only 1 because these are not significant. Therefore, number of significant figures in the first case is only 1. The number of significant figures in the second case here, these are not significant. Significant 1, 2, 3, 4, 5. Therefore, number of significant figures in this case is 5. In this case, it is 1. In the next case, it is 5. And in the third case, number of significant figure is only 1 because this is not significant. Therefore, this are not significant, these are not significant, and this is not significant. All others are significant. Did you understand? Now, rule number 4, and rule number 4 is our final rule. Write down rule number 4. So listen to me first. Rule number 1 had nothing to do with zeros. Rule number 2 was dealing with zeros that come in between the numbers. Rule number 3 was dealing with zeros that come before a number. Now, rule number 4 will deal with zeros that come after a number. So write down rule number 4. If zeros come after a number, if zeros come after a number, and if the number has a decimal point, if zeros come after a number, and if the number has a decimal point, then the zeros are significant. Then the zeros are significant. Then the zeros are significant. Else means if the number does not have a decimal point. Okay, else if the number does not have a decimal point, else if the number does not have a decimal point, else if the number does not have a decimal point, then the zeros are not significant. Else if the number does not have a decimal point, then the zeros are not significant. Else if the number does not have a decimal point, then the zeros are not significant. Clear? That means, listen to this. If there is a number like this, 11800. Okay. Now, here I have 2 zeros which come to the end of a number. Now, does the number have a decimal point? No. That means these 2 zeros are not significant. That means number of significant figures in this case is only 2. But if there is a decimal point over here, for example, then can I say, are the zeros at the end of a number? Yes. Are the zeros at the end of a number? Yes. Does the number have a decimal point? Yes. Then 1, 2, 3, 4, all are significant. Doesn't matter whether decimal point is 180.0. Can I say in this case also there are 2 zeros at the end? Correct. Does the number have a decimal point? Yes. Therefore, these both are significant. Therefore, still the answer is 4. Did you get it? Now, tell me with the same logic, only rule 4, okay, 6200, 6.200, and 620.0. Tell me how many significant figures are there in each case. Give me all 3 answers together in a message. How many significant figures are there in each case? First, second, and third. All 3 are given. Give me how many significant. Some are right. Good. Others, give me the answer. Ryan, Shaunath. Okay, good. Soham, okay. Shushti, correct. Samya, correct. Jenny, check your second answer. Arya, correct. Okay, look at this. Look at this. Can I say in the first number, there are only two significant figures because these two are not significant because number does not have a decimal point. Tell me this. Can I say two zeros are there, but number has a decimal point, therefore all four are significant? Even over here, two zeros are there. Does the number have a decimal point? Yes. Therefore, four zeros are significant. That means both. Therefore, answer I was looking for is 2, 4, 4. If you have given me this answer, that means your answer is correct. Otherwise, your answer is wrong. Just check what answer is right and wrong. 2, 4, 4 is our answer. Clear? Now, final exercise. Tell me how many significant figures are there in each case and give me the answer together. Now look at the answer. Tell me if you have got all right. If you have a doubt in anyone, let me know. I'll explain. Otherwise, I'm expecting all of you to get all of these right. Some are correct. All of you confirm. If you need explanation in anyone, let me know. Srishti, very good. Clear, all of you? I'm assuming significant figures topic is clear because all the four rules are clear and we got these answers. Any doubt, let me know. Okay, need more example. Okay, they have asked for more example. I will give you last 4 examples. Start. Last 4, then we stop for today. Give me the answer. How many significant figures in this case? Samya, Omkar, Ayan. Shonit, check your third and fourth answer. Shushti, correct. Okay, this is the answer. 3332. Tell me, are you getting this answer? 3332. Done? 3332. Most of you have given me the answer, have given me the right answer. Okay, so with that, we will stop our topic today. We will continue in our next class. Okay, so thank you all of you. I will see you next week. Bye-bye.
Bye.
Thank you. Bye-bye.
Sir,
Any doubt? Let me know.
sir, I had doubt in the test question.
What's up?
Sir, the question was differentiate between if it is for 3 marks, then how many points you have to write?
4 points. This is primary cell and secondary cell, correct?
Yes, sir.
You will get +1. I think everyone has been given only 2, correct?
Yes, sir.